Thank you. And maybe some ways it can go right. We would like that. It's funny, you almost said Kafka. Happens to me all the time because I've spent a lot of time in the Kafka space talking about Kafka, so sometimes I do that. And we just launched a podcast at StarTree called the Realt-Time Analytics Podcast. I used to record a podcast at Confluent called Streaming Audio, and sometimes in the introduction I have to do 2 takes because I say, so I just want to say I feel you. It's very much me. I've been more than a year here at StarTree. It still happens. I don't call my kids the right names. I mean, who really does? Anyway, yeah, I want to talk about how to build a real-time analytics database. We'll talk a little bit about why you didn't want to do such a thing, briefly. I've got a similar talk tomorrow that's a little more Pinot focused and gives a little bit more of the context about why you would want to do a thing like this. There's a little bit of overlapping material between the two, directly overlapping, but otherwise they are complementary. So if you're thinking about that, there's that. And I thought doing this as a choose your own adventure journey would be fun, because when you think about how a database is made, there is definitely not just one way to do it. There are so many databases because, not because we like as a people to duplicate effort, but because there are so many trade-offs to make. And so exploring the tree of those trade-offs sounded fun to me. And doing it because I am a person who grew up in the United States and a person of a certain age, I am familiar with these choose your own adventure books. So I imagine many of you here are. Some of you may not be. So these were young adult fiction novels they actually started in the late 70s. They were all the rage kind of when I was an adolescent, so a little bit of time ago. And you would read a few pages, and it's usually some kind of fantasy or science fiction thing, and then you'd have a choice to make. And you say, if you want to open the cage and let the bird out, turn to page 53. If you want to pick up the cage and walk to the next room, turn to page 37. It was kind of hypertexty, right? Before there was HTML or HTTP or anything. And it's pretty cool. Usually you just died. And I actually didn't like them for that reason. I'm like, this is lame. Can I just turn to the page where you live and get the job done? Anyway, so, but it's a fun way to kind of explore the choices that we have to make in making a database. And database there we are. Easy to say, hard to build. As I said, there is no one. And it's appropriate to kind of walk through this, think about the choices we make and the impact they have on one another. And I'll really say, I'll just summarize this briefly. Shameless plug, that's a video of me talking about what real-time analytics is. So that QR code will get you to a video of me apparently writing in thin air. Before you ask, no, I'm not writing backwards. Yes, I actually do know how to write backwards. It's a little messier than forwards, which is saying something, but it's reversed in post-production. I'm writing on a piece of glass that's illuminated. So anyway, briefly, real-time analytics is not about powering faster dashboards, okay? The analytics and broadly the OLAP tradition as it comes to us in 2023 is mostly oriented around powering dashboards. And dashboards are the successor to what was, when I was a younger man, a printed report, right? That's the form that reports take these days. And if a dashboard refreshes hourly, that's like great for most business analysts and decision makers. They don't need it to be in 70 milliseconds. Would that be cool? Yeah. Is everybody gonna pay for it? No. So this isn't really about dashboards. It's not about being a better BigQuery or Snowflake or Spark or something like that. It's about taking data in a system. I think that the driver for real-time analytics is to take data in a system and to turn it into a feature of an application. If you think of meal delivery, this is one of it's not the inception of real-time analytics in the modern era, but it's a key use case. And with only a little bit of exaggeration, it's hard to get a meal delivered on planet Earth without, well, specifically Apache Pinot being involved, but just one of the real-time analytics databases. That's a use case, because I've done a search, and now within some geospatial polygon, there are the burger joints, which was a struggle for me last night, by the way. After the reception, I didn't get lunch. I was really happy. I didn't want to walk a big, long distance. I found a burger joint. It was an hour-and-a-half wait, because there's some other conference in town, and I just was incensed. Anyway, I didn't use one of the Pinot-powered services, that might have helped me, but that's an example of a real-time analytics thing, right? There's lots of restaurants, lots of meal delivery events to be computed, to be filtered over, and then aggregated. And when I enter a search thing, I'm synchronous, I'm looking at my phone and I want it to be alive and tell me something. 7 seconds for a big query is not gonna happen. I'm not gonna wait around for that, it's gonna feel dead. I'm gonna just go walk and engage targets of opportunity and hopefully not go to bed hungry. So that is kind of the orientation. It's analytics that face the user, that's the goal. Talk more about that in tomorrow's talk in more detail, but I just want you to know what we're after here. Did you know boxed water is better? It tastes like other water, it's just in a box. All right, let's start asking some questions and going on this journey. Oh, hey, my clock is not running. That's probably not an accurate time. There we go, that looks much more like it, thank you. What do you want to do with your data? That's a valid question. Like, what do you want? When I ask that question, the correct answer is, it's not that simple. Yeah? The notebook, anybody? Okay, all right. Then maybe I want insights, maybe. So maybe I want to remember what has happened. Maybe I want to keep track of things. Maybe I want to understand what is happening. And really that's about insights. And that's the kind of the fundamental theorem of analytics is I'm trying to get insights that I can take action on. But these are all valid things to do with data. Only the third one is really the analytics question. But what if I want to remember stuff? That's fine, right? Well, then I probably want to log and I probably want a distributed log. I just need to remember the things that have happened. It turns out that that's an incredibly useful thing to do. This is not a foil to set up the glory of analytics. It's really important just to keep track of events, and that's what Kafka does, right? That is what Pulsar does. That's what Kinesis does. There's options here in the world, and Kafka seems to have the lion's share of attention from the people who build things. But this is great. If I just want to remember stuff, I want to log, that's a very, very powerful abstraction, and great. But that's a choice. We're not going to actually take that choice. What if I want to keep track of things? Well, this is more of a transactional database at this point. Okay, most of if my mission in life is to keep track of things, probably my application is some species of CRUD over entities plus RBAC. And I don't mean to be reductive, but that's kind of what business software is. And sometimes some of these descriptions are just depressing, right? Yes, CRUD over entities with RBAC, okay. That's what I've done for the last 10 years. And I've taken HTML form submissions and serialized them in a way I can write them to a database and then read them back out and serialized them into JSON and sent them on. And is that really it? Don't think about that right now. Yeah, but that's fine. That's kind of what we do. We have solutions for this. There are all kinds of great things. And everybody has their choices. I think that an interesting way to kind of summarize what OLTP is about is that there's a focus on this thing. Okay, there's a row. You want to be fast at writing a row. I want to be able to recall a row quickly. That is not the only thing I can do in SQL. There are other kinds of queries. Sometimes you want to get a bunch of stuff back and page through it. That's great. That's kind of another OLTP use case, but the general focus is on a thing. That's what they tend to be optimized for, and that's what most of our application software use of OLTP databases is on a thing. Now, what if I want to understand what has happened and I want to get insights? Okay, this is an OLAP database. So instead of entities, I usually have things that we talk about like measurements. There's some number that I'm recording, and there are other, there's sort of things about that number that we call dimensions. So there's the temperature in the room. That would be a measurement, and dimensions are things like the kind of building that room is in. Maybe the floor, if it's a multi-story building. Maybe the postal code or the region that building is in. These would be dimensions of that measurement. These are all just columns in a table, right? But you tend to think of dimensions as measurements, and again, you're looking for insights, you said it, and you're 100% right. That's what you want. As much as a transactional database is focused on this thing, an OLAP database tends to be focused on these things. There is, in the engineering of the thing, a desire to optimize scanning, because most of what I'm going to do is read a bunch of measurements. I'm going to do some filtering and try to, read at the smallest number of measurements that I can just to get to the set I want, and then compute some reducing function over those measurements. That's a fancy way of saying I do a lot of sums and averages and things like that. Maybe some cooler reducing function. That's cool, but yeah, I want these things. I scan, I aggregate, and so it's usually optimized to do lots of stuff at once. All right, so that's what we're going to do. Next question, and by the way, our choice is analytics, so it's that third thing. How do you want to represent your data? Well, I could do key value pairs. Cool. Documents, like some JSON kind of thing. I could do tuples. Probably other choices, but those seem to be the ones that are common. Let's think about those as we go through this choose your own adventure journey. Key value pairs, suppose that's my choice. Well, you have died. Okay, so again, it happens a lot. You haven't precisely died because prior to the advent of the products that present themselves to us as real-time analytics databases, Pinot, Druid, ClickHouse, Rockset, these things in the space, you kind of had to compute pre-aggregations from your slow non-real-time analytics store and stick them in a key value store, because key value stores are super fast, all right? So that's the thing. It's not as database infrastructure, this is not a good data model. It's not a good option. It will come up later. It may come up later in our discussion, but we're going to dismiss this because we died. This is like Tim reading Choose Your Own Adventure book in 1984 and wondering why all his friends are so excited about these things, because they're stupid, because you just die all the time. All right, documents. Let's talk about documents. So this is kind of neat. We have seen tremendous success of a well-known document database over the last 13 or so years. You get schema flexibility generally. A document is like a bundle of key value pairs where you can nest bundled key value pairs within it. It's just that when you do this, then it really opens you up to a lot of choices you have to make. There's a lot that is open territory. And Mongo is really the database that did this. It's a transactional database. It's not an analytics database. Can you compute analytics with MongoDB? You can, just like you can with Postgres, and just like you can with a key value store if you're into that kind of thing. But generally, not really an analytics solution, and it is, yeah, again, it's cool, but it's not where we're going to go. Let's look at tuples. Okay, so if you've chosen tuples, you're normal. This is it's not quite 15 years ago. I guess 2010, when the NoSQL revolution was happening, everybody's like, we don't need tables, they're stupid, and SQL's stupid, and we can do all these other things. And I think that was an interesting and useful and necessary period of elaboration on the database theme. But what happened was, a few years later, people tended to rebuild SQL on top of whatever it was. You just tend to want that back. And it is, I won't know what kinds of abstractions we'll be using in 100 years. I wonder if tables will still be there. It seems useful. So what you're doing here is really inheriting a very useful intellectual tradition and practical tradition. Is it tables? Can I use SQL? Yes and yes. I don't really need to tell you about the data model. My talk tomorrow is just an intro to Pinot talk. And I don't talk about what the data model is and what the query language are, because it's just boring. I'm not going to tell you what a table is. It's insulting, right? So you get to inherit this tradition. It certainly implies tables and the relational algebra and everything. And this makes me think, this is a little bit before the 80s. I think this was a late 70s issue, before I was reading Iron Man, or before I was reading any comics. But it makes me think of this story arc in The Invincible Iron Man, where Tony is fighting Dr. Doom. Yes, Dr. Doom was kind of more of a Fantastic Four villain, but hey, same universe, it's fine. And some bad stuff went down, and he ended up back in time, in the time of King Arthur, and his suit was damaged. And of course, he didn't have his lab and his parts and all that stuff, and he had to working tirelessly to recreate the whole history of the electronics revolution in 2 weeks with, the materials available to him in early medieval Britain. That's kind of what it feels like when we leave the table and SQL-based world. Like, there's just so much stuff we got to make up, and it can be done, but is it a good idea? I don't think so. So we're going to stick with what we got. All right, now we got tables. Oh, don't do that. My goodness. Okay, keep my head up. We have tables, and now we want to start to think about how we're going to store things. And we have a question about how we're going to serialize our data. Do you want to serialize it by row or by column? And if you haven't thought about this, haven't looked at how databases work, if you weren't a computer science major, didn't take a database class, this is an interesting question. I was a computer engineering major, by the way. I never took a database class. I had to learn all this stuff later. So let's look at serializing by rows. So I've got tuples. We've decided tuples, or documents, whatever. This means I'm going to take that whole thing and turn it into bytes and put those bytes on my storage medium sequentially. Right? Batch up the key value pairs, stream the bytes into whatever the cloud blob store disk. We haven't talked about storage yet. This is OLTP aligned. Okay, this is focused on a thing. So if I'm going to need that row back, and when I want to read something, I'm going to want the whole thing. This is the right thing to do because I put it all in one place, and it's going to be more efficient. Whatever the underlying storage medium is, almost certain to be more efficient to read that thing as in one shot. Now, OLAP gets done this way. As I've said, it's not that you can't do analytics queries with row-oriented traditional relational databases, but this is optimized. This is not optimized for OLTP, so we wouldn't want to choose this path if we're making an analytics database. So let's talk about column storage, a column database. Recalling that OLAP wants lots of things, and what that really means is there is some column, some measurement, that's a column, and we want to scan lots of values of that column and aggregate them in some way. That means that we're going to store we're going to store serialized things, say, to disk by column. So storing a table means I've got all the columns. So the first column is, I don't know, postal code. All the postal codes, there they are in a row. Then the temperature of my smart thermostat, there's all the temperatures stored next. So I break that table down and organize things by column, which seems very counterintuitive if you haven't thought about it before, since our abstraction is a row. Like, where's the row? Put the row somewhere. But again, if we think about the way we're accessing it, I want to optimize that scanning of that measurement best I can. So we organize things by column. Good enough. That's our choice. So analytics, tuples, columns. I'm trying to keep track of all the choices we've made. Let's talk about query language. I'm going to give us 4 options here. We have a lot of choices. We could say none. We could say some snazzy custom API lets us write code and do cool things. We could make up our own language for queries because we don't have one and we know better. I went to this burger joint once, and they had lots of cool burgers on the menu. And they had one that was a build your own, and it was, I can't, being recorded, and it's like not a work-safe thing, but I'll bowdlerize, we'll say it was called the jerk, except it was a different word for jerk there on the menu. I'm like, oh, so you know better than we do, and you want to tell us how to make your burger instead of we, the burger experts, with our carefully curated choices. I'm sad to say that is the one I did, and so that's kind of this, right? Like, yeah, there's all the, but no, we'll make our own, it'll be better. Or we could do SQL. So let's just, I wonder how this is gonna go. All right, let's say none, you died. So again, this is just a thing that happens. This is fuzzy boundaries here, but I feel like this was Hadoop. In the strictest sense, MapReduce was an API, but such a minimal one that it's an insult to APIs. So it was not any kind, it was really a tax on human flourishing. And it's interesting, it's not that, I mean, Hadoop itself and if you talk to folks, I was not active in that world in, say, 2010, 2011. But if you talk to like early Cloudera or early Hortonworks people, and then their experience later on of what those implementations was like, Hadoop proper, it's not clear that that was something that produced net value over time. As a technology, as an approach, if you look at its children and grandchildren, it is epoch making. Okay, so this is not to throw shade on Doug Cutting or Hadoop or anything. Very, very important piece of technology. Very difficult to overestimate its impact on anything we're talking about with data these days. That initial API was trash, and we all knew that. Hardly anybody actually implemented map and reduce and wrote code. That was like early adopter stuff. And right away there was what happened? Hive. We were writing SQL, or there was cascading, or just other layers on top of it. It was terrible. But yeah, you don't want none. That's just a way to die. And that was our collective judgment also. It got wrapped in things. And frankly, I think that was one of the hard things about the Hadoop ecosystem, is that it cried out so much for extra layers on top that those layers proliferated, and you had this crazy zoo you had to navigate. And anyway, let's talk about APIs, because this is happier. And this is a thing that I think remains a first-class part of your toolbox in the real-time analytics world. And I'll just say Kafka Streams or things like it, right? I kind of come from the Kafka space, so this is what I think of first. But honestly, Flink would be a very appropriate thing. You get the same kind of thing. You've got an API, and you get to write code on top of abstractions and feel like a person, and not somebody who's just getting beaten. So the bummer, and particularly in the case of Kafka Streams, you can use any language you want as long as it's Java or directly adjacent to Java. So that is not a limitation if you're using Java. It is if you're like a Python shop. It just doesn't get adopted there. And this is sometimes very, very good. This is exactly what you need some of the time. It's nice to have options like this. So again, not set up as a foil at all. We're not making this choice today, but it's a choice that people could make. You can do your own query language. Again, like that hamburger option. It's not necessarily a bad thing, and it is, again, it's what Mongo did. Just think of the amount of energy it takes to do that, though. I mean, that's hard to do. It's hard to make up in a useful way. It's hard then to communicate to the whole world of developers, hey, guess what? We have a brand new thing. It's fun. And I mean, the histories will be written about what a good job they did at that. Also interesting, if you look at the docs now, every single thing is explained with SQL. This is like select group, and isn't it though, right? So it's hard to do, and it's at least it will be conceptually derivative of SQL. SQL is about my age, and it is proving to be a hard habit to break for us. Okay, so again, normal person, you might try to avoid this. We've done it. It happened during the NoSQL revolution. You will probably fail. And again, this is a thing where you are inheriting a substantial tradition. Everybody knows it. There's classes. People learn it. If you didn't come up through a traditional computer science education, there's a billion YouTube videos and Udemy courses, and it's just easy to learn. It's there, and we understand it. So let's choose this. All right. Thinking more about storage, like where do we want to put stuff, actually? I was kind of fumbling around a minute ago, and I said something like, well, let's just say we're putting it on disk, right? Just don't be too general. It's disk somewhere, right? But hey, this is a question. How are you going to do that? Is it going to be all a cloud blob store, like some cloud native thing? Is it going to be flat JSON files on disk? The DuckDB people tell me that's really all I need because my laptop is very fast, and I should just have everything in CSV or JSON, and it's good enough. That's a choice. Log structured merge tree, page storage, I have choices to make. But I really feel like I can't answer this question until I answer this question, which is, can things change? Is data mutable? So 2 options, yes, and not much. The assumption in the analytics world is that we're talking about things that have happened. And as we know, things that have happened are tragically immutable. You can't unmake that decision. You can't take those words back spoken in the heat of the moment. The event has been produced to the log, and you have to deal with it, right? So you are mostly looking at immutable data in analytics. Now, big asterisk there, and this is a hot topic among the real-time analytics database contenders, is are upserts useful to do? But let's just look at the options to see what our choices are. Okay, so if we have mutable data, then the implied storage architecture historically that we're gonna have is something paged, right? Got some big chunk of file system and I break it up into pieces, and if I want to change a row, then I'm gonna go find the chunk, the page that row is in, I'm gonna read it, I'm gonna change it, I'm gonna write it back. That read, modify, write. And that works. That's a great way to do mutable storage. It doesn't really support high write workloads. So if I have a very write-heavy workload, it's hard to do that well with the read, modify, write thing. So there's also the LSM tree. And this is not a talk about LSM trees. I think they're an increasingly commonplace structure. If you don't know what they are, I recommend you chase them down and get to where you know what they are. They show up in lots of places and are a cool way to handle mutable data when you have write-heavy workloads. It's increasingly showing up. RocksDB is, I think it comes from Facebook. Am I supposed to say Meta now? I'm not gonna. It's an increasingly popular component, and there's even a real-time analytics database that's based on it under the covers. So for handling data that can change, those are the things. But we're not gonna do that because we're mostly immutable, and I still can't really answer the question now. As we're going down this part of the tree, what do I want my storage to look like? If my data is immutable, always that asterisk, mostly, might want to do an upsert sometimes. But if I'm basically looking at events, now I need to know something about dimensionality. So I mentioned before that we're focused, the kind of structures we're focused on in analytics are measurements and dimensions. I gave the example of a smart thermostat network, and the measurement was temperature. We could say humidity and pressure too, let's be cool. And I threw out some dimensions like building type, floor, room size, postal code, et cetera, those kind of attributes of that sensor. Dimensionality is really a question about my access patterns. How am I going to be reading that measurement? It reduces to how many indexes do I want? So let's go down that path. How many dimensions does a table have really means how many ways could I want to filter this data? What things could show up in my where clause? My options are 1 and lots. Let's look at 1. All right, if you only need 1 index, then something like Kafka Streams works well. And there are various other streaming SQLs. There's Delta Streams, there's Materialize. There's still, in some sense, KSQLDB at Confluent, I think, with their pivot to Flink. That's probably a less common thing in the future. We'll see, probably, my guess would be that we'd see less investment there. But that stuff, if it starts in Kafka, you're limited to 1 index. That's the key of the topic, of the messages in the topic. So those solutions work well there if there's really just that 1 dimension. Cassandra, it's, again, there are ways of building secondary indexes, but fundamentally you build a table around a single primary key and you do very fast lookups. Not an analytics database, again, you'd have to do pre-computation there. RocksDB, if you were using it individually, same thing, you're gonna have a single index. And frankly, remember I said before, key value stores were a way to die? Well, here's a way you dodge the bullet. If your dimensionality is 1, then you actually can realistically pre-compute aggregates, write them to a key value store, and away you go. And that might not be too bad. So there you are. Now, yeah, again, I said before key value stores were bad. The reason why they're not a super practical option is because analytical data and analytical queries are typically highly dimensional. So we talked about the smart thermostat answers. This bullet here sounds vaguely ad techy, which I guess is, we have at StarTree, Pinot doesn't come from ad tech. It comes from LinkedIn. It comes from social media. So ad tech does not dominate the use cases that you see, but there are some ad tech things. And we actually made a video with a customer that is an ad tech play. And it was like the most humanizing ad tech story ever. They're like trying to serve ads in sort of hobbyist blogger, think a recipe blogger kind of thing. It was like just the most wholesome ad tech story ever. So ad tech doesn't mean bad things. Anyway, yeah, like my browser, my location, my OS, my screen resolution, all those. Usually those things show up in dimensional queries. So typically a key value store is contraindicated, right? But because of how dimensional our data is. So let's look at what happens with when we have lots of dimensions. So here, to talk about this, I'm kind of just going to break character from the choose your own adventure thing and actually talk about how a few indexes in Pinot work, because I think it's just the most interesting way to cover the material. And this is tomorrow's talk. That's really about how Pinot works. But to be a real-time analytics database, you need to be able to ingest data real fast. There's probably an event stream that you want to ingest, right? There may be batch stuff lying around, but there's probably this big thing that you're going to bolt a Kafka topic onto, practically speaking, right? So you're ingesting data real fast. That's the right path. That's ingest. And the rest of the equation, apart from all these internal architectural decisions, is how can I read that? Which is, what cool indexes do you have? And do they serve the access patterns that I have such that I can get fast queries at the latencies and concurrencies that I need? So yeah, you get to indexes. Let's look at indexes. There's one. This is a little confusing at first. It's called the forward index, and it looks confusingly trivial. Like, why would you even have that? I want to remind you, rows don't show up all at once. Okay, we have these chunks of column data. And so when I want to look up a value or find where a value is for a row in a column, I actually need an index that tells me, if I know the row ID, we're going to call that document ID, the internal representation, unique identifier of that row. If I have that document ID, where in the column chunk of data is that value? That's what the forward index does. Where is row X? Because bits of rows are stored everywhere in our internal storage representation of the table. So I really want to know, where is this column value for this row? And rows are things, again, I'm going to use this term, document ID, that define what an individual row is. So now, it's very important when you're trying to design a slide to explain something that you bend the nature of practical reality to suit the layout of the slide. So this is one of the hazards of what I do, and why it's always really interesting for me to talk to the people who are actually using the technology in anger, because the world out there and the things the business wants don't give a crap about how Pinot's designed. That's people wanting things, and then it's the interesting process of adapting, the sort of world of human beings to what the tool wants. But I get to make up single column tables to illustrate my point, so it all fits on the slide. All right, so the first column there is document ID. That wouldn't be an actual part of the row that you see. The second column is just city. So we're just taking this little projection of a table. And so yeah, if I have a document ID of 0, that's going to point to my column is called location. I'll point to that. Also, document ID 1 points to that same location. Document ID 2 to Mountain View, 3 to Prague, 4 to Mountain View. You see how it works. It's just telling us where things are. And by the way, this compressed encoded thing is a thing that happens with lower cardinality columns. You'll use what's called dictionary encoding. So you don't have to store the whole thing. You just have document IDs that point to little things in a dictionary, and that worked great. Now, inverted index, opposite. So this is answering the question, what rows does this value occur in? So if I know the value, what are the document IDs? And it looks like this. So if I have the term or the value, say Littleton, well, that's the list of document IDs where that occurs. Useful. So if one of those low-ish cardinality values occurs in a where clause, I can just zip right out of the index, I get the document IDs and deal with them in memory. I can build Bloom filters on columns. So the storage, it's a distributed database, whatever this kind of thing is, and we'll get to that in a minute, but I'll have lots of little pieces of table on different machines, and I'll want to know, should I even bother looking in this table for something? And a Bloom filter is an in-memory structure that efficiently stores in memory either you definitely should not look there, or maybe you should look there. And so if it says, no, don't bother, then we know for sure I was not going to find my thing in that chunk of storage. If it says, yeah, you should try, then maybe it's a 90, 95% chance. I might come up empty, but that's fine. It's still money well spent. I've given a little bit of memory and a very fast memory lookup to avoid a slow storage lookup. Text indexes. So if I've got something that's some text blob, I'm probably going to want to do, I don't know, regular expression matching, prefix matching, Boolean combinations of things, and I can do all those kinds of things with text. It's like having a little embedded Lucene just on that one column. I think in the case of actual Pinot, it used to be Lucene, and I think it's now its own text index. All kinds of cool things you can do. There's the geospatial index, worth its own whole talk. So let's just say there's a geospatial index. If you, shameless plug, if you follow StarTree on YouTube, a guy on my team just made a video last week that's all about how this index works. It's like 7 minutes long, and he actually explains it fairly well in a short amount of time, which is pretty cool. But Uber, by the way, again, this is the Pinot specific part of the talk. Uber and LinkedIn are big committers to Pinot. Kind of Uber, LinkedIn, StarTree are the three companies that put the most into it. Uber adopted it for their meal delivery service. Uber, of course, is keenly concerned about the locations of things. And so they had this geospatial library that they adapted to this index type. And the whole indexing system in Pinot is super pluggable. So it's even service provider based. You don't have to rebuild anything, just put a jar in and you've got a new index. So it's kind of cool. You'll likely to see future innovation in the indexing space just because it matters a lot and they're easy to change. JSON, so if you're ingesting a column that is itself JSON, I can do various kinds of lookups. I can do array indexing, wildcard array indexing, traverse the tree of JSON documents. Timestamp, oddly this is a fairly new one, which always gets me because, again, just as a Pinot thing, you can't have a table that doesn't have a time column. So I've been asked, is Pinot a time series database? I'm like, yeah, no. Can I have a table without a time? Also no. So nobody would describe it as a time series database, but time is necessary, and that's just how it works. So this is kind of like an inverted index. What are the documents, what are the rows that happen in this time, that have this time? And you get to define the grain on that. So if there's a timestamp with, say, millisecond or nanosecond resolution, whatever it is, you truncate that according to your definition of the grain. So suppose you had day, then you'll get this kind of thing where whatever that timestamp is, everything past day just gets set to 0, and I group together all those documents that happen in that truncated version of the timestamp. So it's building on the already existing range index type. The StarTree index, not to be confused, actually that's a misspelling on that slide. I would like to apologize. That should be star-tree. StarTree with this capitalization, that's the name of a company. So that's an implementation detail that has leaked into the interface. It's a cool company name, so it works. But this is a nifty index type because there is this common access pattern where I've got some measurement, I want aggregates, like I want the total number of, I'll go back to ad tech, impressions based on country, locale, and browser type, or in order, country, browser, and locale, right? And I might want, all the impressions for Canada. I might want all the impressions for Mexico and Safari, or Mexico Safari, but with the English locale, or something like that. And those are my access patterns. You can do that in Pinot. You can build those indexes and compute the aggregates, or you can have Pinot pre-compute those for you. So it's not a system where it's making you pre-compute aggregates, but it will do that in building the index, and it builds this tree that's got all of those levels of aggregations actually stored in the index. So it doesn't have to do any scanning of the measurement, it just reads the value out of the index. And so you get this big explosion of all these documents in the index for those aggregates, and you get latencies, query latencies on this kind of data that look fake. The benchmarks look like somebody's clearly lying because, again, it's all in the index. It's pre-computed, so it's super fast. Okay, done with indexes. We're off that side quest. Let's get back into some choices that we have to make. We could ask how fast you need it. Now, you're like, well, 0 time. Of course, I want it to be as fast as it can be. Yeah, but we're engineers. We make trade-offs, and we're spending money effectively on things. So there's dashboard speed and there's UI speed, like I was talking about before. Now, your CFO does not need real time. It's not worth it to spend real time money on faster dashboards. Can you make it 1,000 times faster? You probably can. Maybe 300 times, maybe 500 times, maybe 1,000 times faster. You don't need 1,000 times as many dashboards. You don't need 1,000 times faster refresh rate on that. It is not a thing to spend money on. So dashboard speed, reporting documents, queries that take seconds are fine. Batch ingest is maybe fine. I mean, increasingly you still want streaming ingest here. And query latencies that are 5, 10, 15 seconds, it's great. Do it, ship it. That's the whole analytics tradition that we have. And as I said, not Hadoop, but now Hadoop's grandchildren do that for us. And it's good. So the real-time analytics question really doesn't set itself up against that stuff. Now, if you've got one of the real-time analytics databases in your life, can you also build dashboards on it? Yes, I happen to do that for my team. I collect a bunch of metrics about everything, and of course we dog food our cloud service. Why would we not? That makes a lot of sense for us. That can also happen, but nobody's gonna get there that way. You're gonna get there through UIs. And this is where 100 milliseconds might seem like a really long time for a query latency. You need streaming ingest. You need, depending on your scale, 100, 1,000, 10,000 queries per second hitting the database, depending on how big the population of users is using the thing. You just get that kind of explosion in orders of magnitude of people using it, from 10 to the 0, 10 to the 1, to 10 to the 3, 4, 5 kinds of concurrencies. So that's a choice. And of course, how do you want to scale? Well, you could say single process, which is to say you don't want to scale, or distributed, you do want to scale. Single process, this is great, by the way. This is DuckDB. And their whole argument is your laptop is super fast, your data's not that big, and you should do everything you need in this little tool. Plus, it's your storage. Who else is going to touch it, right? Like, it's great. It really is. I mean, you go home at 3:30 if you do this non-distributed life. I strongly recommend it. Then when it doesn't work, you've chosen a technology that assumes it has control of the whole universe. And so you have to like shard and it's then all of a sudden the dream turns into a nightmare. Happens to everybody, no shame. But that's a choice to how to scale. If you do need to scale compute and storage, and you probably do, and again, there's just any number of choices on how to do this. And for that, come see my talk tomorrow. Make your choice tomorrow. I'm not just trying to plug my talk, but that really is just a broader discussion. Okay, I want to scale compute and storage. There's no general answer to how to do that. You just kind of have to take it piece by piece and say, how does this product do it? How does that product do it? And that's where we get. So finishing up, if this is actually not the same light board. This is a 10-minute, this is Pinot, intro to Pinot thing. If you don't go to my talk tomorrow and you care about Pinot, go see that. But it talks about these ideas of latency, concurrency, and freshness. Talked about latency a lot. Queries have to be fast. We talked about concurrency. There may be many queries happening at once if it's user-facing. Freshness, we want to ingest streaming data and have it queryable effectively right away if possible, right? So those are kind of the three things that separate, the three dimensions that separate the real-time world from the not real-time world. And yet another QR code. This is our Slack workspace, great place to come. There's discussion, there's resources, there's Q&A. Everybody wants another Slack workspace. You know you do. So check it out, and with that, thank you.